Hello all. Today in this lecture we discuss about control system. So what is a control system? So an example of a control system is an to control any room temperature is achieved by switching on and switching off of a power supply to a heating appliance. Thus power supply to an appliance is switched on when the room temperature is fell low and switched off when the desired temperature is reached. So control system is means or any kind of um, robotic arm control or any kind of mechanical control is also known as the is also part of the control systems. So in a control system, first two things is very clearly noted, that one is open loop control system, and another is one closed loop control system. Okay, closed loop control system. So what is it that in open loop control system, basically there have an input R. This is a block which is maintained by gain A, and this is output C. So this is output and this is input. So this is the general open loop control system block diagram, where R is the input signal, C is output signal, and say consider this is an amplifier. So in open loop control system, there is no control for the system because there is no feedback is present in the system. So that's why it is called open loop system. And for the closed loop control system, the one more important thing is that in a closed loop control system, we apply here input signal, then here one comparator block is situated. This is not a comparator. Then here the gain is A, and this is a feedback network F dot B, that is feedback network, and feedback is connected through the output network, and this is output. Okay, and this is a error signal, and let's say this is a feedback signal F, and this error signal is basically R minus F. Okay, so this is an input, these are output, and these are feedback network. Now if the output is decreases or increases, then using this feedback network we can change this error signal, and if the change in error signal is done, then the output is also switch from one state to another state, or output is increase or decrease, as vice versa. So closed loop control system are known as feedback control system using power amplifying device prior to the controller, and the output of such a system being mechanical, that is position, velocity, acceleration, is called so known as servo mechanism. So different kind of motor rotation, different types of robotic arm control can be more accurately and precise control by using this closed loop control system. So now we some comparison between open loop system and closed loop system. So first point is that in open loop system, the accuracy of open loop system depends on the calibration of the input, and here as the error between the reference input and the output continuously measured to the feedback, the closed loop system work more accurately. Number two is that the open loop system is simple to construct, and number two is that the closed loop system is complicated to construct and very costly design. Number three, the open loop system are generally stable, but this is can become unstable under certain condition. Number four, the operation of open loop system is affected due to the presence of nonlinearities in its element. But here in this feedback, due to presence of this feedback in terms of performance, the closed loop system adjusts to the effect of nonlinearities presence in its element. Okay, so now one thing should be remember when you study the control system, student, please clearly should be clear the concept in the Laplace transform, because in a control system everywhere we apply this Laplace transform, and in a Laplace transform we already know that any continuous signal given by ft where Laplace transform is performed in it, then the Laplace domain, in a Laplace domain the integration must be represented by this equation. Okay, so this is a Laplacian formation of this function ft. Okay, so there are some property in a Laplace. In the previous video we discussed about the Laplacian property, say for Laplace time shifting property, time scaling property, differentiate property, integrate property, different types of Laplace property are discussed in the previous lecture. Okay, now we study about the block diagram concept in a control system. This is very important, because basically the control system is coming from the circuit theory concept first of all. Okay, these are very important because most advanced and most complicated circuit are designed and their parameters study using by these control system parameters, and in this letter the subject is known as control system. Basically these all are the circuit is a part of the network analysis or network synthesis or network design. So first of all consider one block, and the gain is in a Laplace domain known as GS, and here we apply our input known as RS and we get output known as CS. So these all are in a Laplace domain. So here gain is equals to open loop gain equals to, that is CS by RS, that is Laplace transform of output response divided by Laplace transform of input response. And one condition should be remembered, this is a Laplace transform of output response of all initial condition equal to 0, and this is a Laplace transform of input signal include all initial condition equals to 0. Okay, this is very important. Okay, so now we discuss about some block diagramming method in a control system. For block diagram reduction method or block diagram method, first of all here we apply some theorem in a block diagram. So now representation of a control system by a block diagram. So generally first we seen that there are some theorem which is included in the block diagram reduction technique. So first technique is the normal gain, that is open loop gain. Second technique is that takeoff point. So what is a takeoff point? Say consider here is again G1s, here C1s, and here you apply RS. Now takeoff point means from here you also take one point and multiply by the gain G2s, therefore also here we get the signal output C2s. So application of one input source to two or more system is represented by a takeoff point as shown in this figure. Okay, so from here from two takeoff point are taken. Now block diagram in cascaded from. So what is the cascading rules? The cascading rules is very simple. Now here we apply our RS signal, and here the first block, say consider G1s, second block consider G2s. So the output equals to, basically it is very easy, G1 0 into RS, right? So this is a cascading rule. Cascading rule means just multiply then. Okay, now what is a parallel rule? Number 4. What is a parallel rule? Now first of all this RS is multiplied by G1s, so the output equal to C1s. Okay, and again this RS is multiplied by G2s, and here we add these two signal and get output this C2s. This adder is basically summing amplifier or adder in using op amp. If we realize this block diagram using circuit, so this is an input, this is just an amplifier, either inverting, non-inverting, any kind of amplifier or transistor based amplifier due to the respect of the network analysis. And this adder means the op amp, using op amp or using transistor we can make the adder and this is an output. Okay, so each block diagram represent the circuit representation or network representation in a control system. But in a control, we cannot analyze the deeply analysis of the circuitry, because you all express the circuit parameter in a Laplace domain. So that's the easy to analyze in a using control system. Okay, next one is number 5 is very important, that is called summing point. So what is a summing point? Summing point is basically a point where all signal are coming and get the resultant waveform. So suppose here XS signal is applied, here RS signal is applied, and here Y signal is applied, and this is are in same phase and this is out of phase. So what is output signal? So this output signal is basically RS plus XS, yes, right, minus YS. So this is very easy. So there are some summing point is also apply here. This is a plus and this is a minus. So here we apply RS and here we apply XS, and here, so we break this summing point in a one summing point in a two summing point. Okay, so this output is same. So here also RS plus XS minus YS. So the output is basically same, but here only one summing point are considered, here two summing point are considered. Here first RS and XX are addition, and then minus YS is minus. Okay, so this is a summing point. Okay, now next, number 6 is very important, shifting of a takeoff point. What is that? The rule is shifting of a takeoff point. Okay, what is that? Suppose the input signal represented by RS, and this is an output signal, this is an GS, and here one signal is connected and we here get RS. So now if you shifting this point from here to here, that means here we apply the input signal and here the output signal. Now if we shifting the point here, we already know that the output function is basically GS into RS. So here only we get the RS. So removing this GS, we can multiply 1 by GS. So then we get the output RS. So shifting in the takeoff point means changing the block diagram block value also. Okay, so this is known as shifting of a takeoff point from a position before a block to a position after this block. Okay, next we talk about shifting of a takeoff point from a position after a block to a position before a block. Okay, so now our problem is very crucial, because this shifting point is before and we convert it after, and here first the problem is that here shifting point from a position after a block, that means here first of all the after a block, this is a CS, and if we convert before a block, so what is output here? This RS into GS. So here you apply also one GS block. Okay, because CS equal to this GS into RS, and if we shift this takeoff point before a block, then this only RS, so multiply by again GS, then we get the proper value of CS. Okay, it's very easy. Okay, now next is number 8, shifting of a summing point from a position before a block to a position after a block. Say this is very important. Say consider here two signals are coming, one is RS, another is XS. Say this is plus minus both, and here gain is GS. Okay, so now this is very easy to realize the output. So what is output? The output is basically rs into gs plus first of all, the two signal is basically in the form of this mathematical expression, which is multiplied by gs. This is this is very easy expression. So now, if what is our objective? Our objective is shifting of a summing point from a position before a block to a position after a block. So after this block we shift this summing point. So what we will do that? So first of all, this rs is multiplied by separate gain gs, and then we apply here in the summing point, and here also before we apply xs, it is go through the gain gs. So the output equal to cs, which is same equal to this expression. Okay, and here plus minus, here only plus. So look here, the summing point is before this gain. Now we shift this summing point after the this block gain of block gs. Okay, now next one is very important, number 9. Shifting of a summing point from a position after a block to a position before a block. So I again repeat, shifting of a summing point from a position after a block to a position before the block. So now what is the first expression? So it is first before the block. Okay, there is one summing point here. This is xs. Say consider here plus sign, this is rs, and cs is basically rs into gs plus minus xs. Okay, because first multiply this gain and then addition with this signal. Okay, so we convert this, and in another way we say that we shifting this summing point before this block. So now what we will do that? But now our task is shifting this summing point. So now first rs. Okay, now one thing should be remembered, that here apply before xs, we pass it through the gain gs, because one thing should be remembered here, xs. Okay, so now in this output, the rs plus xs by gs. Now if we multiply this by the function gs, then the output equals to rs gs, yeah, right, plus minus xs. So that's why we here, before we apply the xs, we multiply by gs and then we apply here, because our output is equal to this mathematical expression, because here only xs is applied, there is a no gain with the xs. But if we shifting this summing point before this gain block, then before applying the xx we multiplied by 1 by g, otherwise this xx is multiplied by into g, and the output is not equal to this output equation. Okay, so this is very important. So now theorem 10 is that shifting of a takeoff point from a position before a summing point to a position after the summing point. So what will do that? So first of all, this is one summing point, this rs, this plus. So now here we apply this xs. From here we again get one signal, this is cs. So now our task is that shifting of a takeoff point from a position before a summing point, so shifting this takeoff point. Okay, so our task is that here this signal is same. First of all, there is a no change, but one thing should be remembered, this shifting of this function, that means first of all here the signal equal to rs plus minus xs. Okay, so now if we shifting this takeoff point from here to here, then here we addition one extra summing point. Why? Because this in the second, the first output expression is rs plus minus xx. Okay, so here we apply plus signal, and here plus minus we apply xs. So now rs plus minus xx is from this output, is getting from this output. Okay, done. Next one is that here one thing should remember, in the at this point we get the signal rs plus minus xx, but here you only get the rs. So what we will do that, here we just opposite phases apply the xs. So now here only rs. Why? Because this rs plus minus xs, when coming here, then it out of phase with xs, so this xs is in plus minus and this xs in minus plus. So when this xs is plus, then this is minus, and when this is minus is plus, so they are cancel out each other. So this is the final output or the second output of the rs. So this is the beauty of this design. Okay, so this signal is in positive and this is negative and positive. Okay, this is very important. Okay, now next is number 11. This is also very important. Shifting of a takeoff point from a position after a summing point to a position before the summing point. Okay, now main problem is that this is our block. Here we apply our signal xs, here we apply rs, and now here we getting the signal rs plus minus xs, and here also you output the same output, you getting the same output. Now you shifting this takeoff point, this shifting. Now if we first of all we should be noted that the output is rs plus minus xx. Okay, so now for the first output, this is rs. Okay, here we apply our signal plus minus, here we apply xx. So here in the first output, the signal is rs plus minus xx. So now if we shifting this takeoff point, so what we will do that, because here only rs, so extra one summing point is addition here with plus minus xx signal. So again here the output equals to rs plus minus xx. So shifting the takeoff point means from here to here, that means one extra summing point is necessary to equivalent the same output, or for the same output signal. Now this is unity feedback or one feedback loop system is known as unity feedback control system, also known as unity feedback control system or closed loop control system. Now this is very important. So this is number 12. So okay, now for this, here first of all the open loop gain is considered as a gs. Here one comparator is, or summing point is at here rs, input signal rs, and this is a error signal es. This is a feedback signal known as bs. So this is a plus, this is a minus, this is a negative feedback. Basically for positive feedback this is plus, this is a feedback path gain or feedback gain hs, and this is the output known as cs, and this is the feedback. Okay, now one thing should be remembered, that here this error signal is equals to input minus feedback signal. So what is a feedback signal? Feedback signal is basically the mathematical expression by cs into hs, right? Okay, so now we consider cs by es, then we get gs, because this is error signal in the input and this is a cs. Okay, now cs is equals to this es into gs. Okay, here in the expression of ES, this is equation 1, equation 2, we put the value ES from equation 1. So this is basically RS minus BS. Okay, so now this is GS, this is RS minus, now from the value of BS from equation of 2, we're putting this value, this is a CS. Okay, now in the left hand, from the right hand side and the left hand side, we take the common part GS into HS, and in the right hand side there is only one part. Now CS by RS is equals to GS open loop gain divided by 1 plus GS into HS. So what is this system? This feedback system is also available in the control system book, but what is a relation of the circuit? What is the practical scenario of this circuit? This is very important to realize the control system parameters. Okay, so say just consider this is an amplifier, this is a feedback system. So amplifier means you already know that using transistor based amplifier. This is an C amplifier. Okay, now realize this control system block by circuit to these RC, these R1, R2. Okay, this is the input coupling capacitor Ci, and this is an output coupling capacitor C0, and from here we're getting the voltage V0. Now here this is bootstrap parameter, this small RE. We can control the gain of this amplifier. Here we apply our input signal. We know that. Okay, so now from here, if we control this circuit, then there is a feedback network. This is an HS, and this total block is known as basically GS, the amplifier. Now from here to here we connected our signal, and then this signal is via comparator, any comparator. Then we apply here our actual input signal, the sinusoidal signal. So if there is a problem, or if there is an distortion occur at the output signal of this amplifier, then via this feedback network we can control our output signal using this error signal at this input ES. Okay, so if we change this error signal, then amplifier gain also be adjusted, and we also changes this amplifier gain by using also RE. This is just for an example to show how these block diagram are work to each other, and to control the circuit or the network parameters. So this is very important. Okay, so this is the first lecture of the control system. We talk about the basic control system nature and the parameters. What are the GS and the HS and the RS and the CS and their block diagram properties. So because this block diagram is basically coming from the network synthesis or network analyzing parameter, because in electronics we know that from the view of the circuit theory there are lots of parameter are analyzed in a two-port network, or Z parameter, Y parameter, the control of the amplifier and the feedback and the oscillator output, sustainability of the amplifier, change of the amplifier gain due to the external parameters like a temperature changes, and how to control them. So that's why we represent in every circuit in a block diagram representation to analyze. And one thing should be remembered, all parameters are investigated in a control system in a Laplace domain. Okay, so using Laplace transformation method or Laplacian method, we can say that any circuit is stable or unstable. Okay, how the circuit will be converted from stable to unstable or unstable to stable system. These are lots of parameter study, and this is also known as first order, second order, third order, or nth order control system, or In the later video, we'll be show that the time domain response and the frequency domain response also, and there are root locus method and Nyquist criteria also discuss, and Bode plot also discussed to analyze the frequency domain analysis in the control system of the network parameters.